Higher derivatives. If f is a differentiable function, then its derivative f prime is also a function. So f prime may have a derivative of its own, denoted by f prime prime, or we can say it's f double prime. This new function f double prime is called the second derivative of f because it is the derivative of the function. Using Leibniz notation, we write the second derivative of y is equal to f of x as the following. It's going to be d over d of x of dy over dx. So that becomes d squared y over dx squared. So for example 7, it says that if f of x is equal to x cubed minus x, find and interpret f prime of double prime of x, meaning the second derivative. Okay, so let's first talk about what we did in example 3. So in example 3, we found that f prime, or the first derivative of x, was equal to 3x squared minus 1. So now we want to find the second derivative. So if we want to find the second derivative, that is f double prime of x, which is the same thing as f prime of x, is equal to the limit as h approaches 0 of f prime of x plus h minus f prime of x divided by h. So therefore this becomes the limit as h is approaching 0. And so that means that we're using the function 3x squared minus 1. So it's going to be 3, and we're plugging in x to be x plus h. And then we're going to square that minus 1. And then minus, we want to subtract f prime of x, which is 3x squared minus 1. And that is divided by h. Okay, so now if we simplify this a little further, then we have 3 times x squared plus 2xh plus h squared minus 1 minus 3x squared minus 1 divided by h. And so now let's distribute the 3. So we get 3x squared plus 6xh plus 3h squared minus 1. And then distributing the minus sign is minus 3x squared plus 1. And then divide that by h. Now we can simplify the numerator, so we have 3x squared minus 3x squared minus 1 and then plus 1. So then what we have left is the limit as h is approaching 0 of 6xh plus 3h squared divided by h. So we can factor out an h. So we have h times 6x plus 3h divided by h. So we know we can simplify the h. So now we have the limit as h is approaching 0 of 6x plus 3h. And now let's evaluate this limit. So we have 6x plus 3 times 0, which gives us 6x. So we know that now f double prime of x is going to equal 6x. Okay, so now let's graph all these on one graph and see what that looks like. Okay, so we know that our first function was x cubed minus x, and then our derivative was 3x squared minus 1, and then our second derivative is 6x. So let's go ahead and take a look at that. So let's go ahead and take a look at our graph and then outline what we have below here. Okay, so we know that we just found the second derivative, which was here, and that second derivative was 6x. And then our first derivative was f prime of x, and that was 3x squared minus 1. And then our first function, f of x, was equal to x cubed minus x. So we can interpret f double prime of x, or the second derivative, as the slope of the curve y is equal to f prime of x at the point x, f prime x. Now, in other words, it is the rate of change of the slope of the original curve y equals f of x. Now, notice from the graphs that f double prime, or the second derivative, is negative when f prime of x has a negative and positive when f prime of x has a positive slope. So the graphs serve as a check on our calculations. So let's confirm those last statements on our graph. Okay, so again, what it's saying here is that f double prime here, meaning that this function is below the x-axis, is negative, okay, when our function, our first derivative, is negative. Okay, and then we can say that when f double prime is positive, meaning that it's above the x-axis, then we can see that the slope of f prime of x is a positive slope.